Good morning, children. Today's topic is ionization energy or ionization potential. Ionization energy, according to latest IUPAC recommendation, is also named as ionization enthalpy. An atom is composed of positively charged nucleus and negatively charged electron revolving around it, like this. Positively charged nucleus and negatively charged electron revolving around it. Nucleus exert a force of attraction on the electron. If we wish to remove an electron, we will have to supply appreciable amount of energy to overcome this attractive force exerted by the nucleus. This amount of energy required to overcome this attractive force to remove this electron is called ionization energy. In brief, you can say the quantity, the amount of energy required to remove an electron from outermost shell, that is most loosely bound electron, from an isolated neutral gaseous atom to convert it into monovalent cation is called ionization energy. You can represent this by the equation also. Suppose M is a metal and E is the ionization energy. Then its ion M plus is formed after the removal of electron. M is a gaseous atom. Isolated atom. Isolated atom means, what is meant by isolated system? Isolated atom, a system which can neither exchange energy nor matter with the surrounding is called isolated system. A system which can neither exchange energy nor matter with the surrounding is called isolated system. Suppose you are keeping some milk, tea in the thermos flask, then its heat cannot go out of the flask, and from outside also heat cannot enter the flask. Vapor of that tea or milk kept in the flask cannot go out, or vapor from outside, water vapor from outside cannot enter the thermos flask. Such systems are called isolated. Then this is isolated atom. Now next point, measurement. Ionization energy is measured either by a spectroscopic method or in a discharge tube containing gas or vapor of the element under study at low pressure. The voltage, the potential difference applied in the discharge tube between cathode and anode is most important. On increasing the voltage, potential difference between cathode and anode in the discharge tube, gradually a stage is reached. A stage is coming when the gas in the discharge tube gets ionized. This ionization stage is indicated by the sudden large increase in the flow of current through the gas. The voltage, the potential difference at which the gas get ionized is called ionization potential and is numerically equal to the ionization energy of the gas under study in electron volt. Ionization energy and ionization potential indicate the same thing but in different units. Ionization energy unit is kilojoule per mole, kilocalorie per mole. Ionization potential is electron volt per atom. Now, some more thing I want to tell you, electron volt. Actually, electron volt is the energy of an electron moving in the fall of potential of 1 volt, that is moving in the potential difference of 1 volt. 1 electron volt equal to 1.602 into 10 to the raised power minus 19 joule. How it is coming? It is actually energy, work done, work for electron. Here it is charge on electron multiplied by 1 potential difference, the value will be this. If you want to get its value in kilojoule, divided by 1000, you will get its value in kilojoule. Now, next point I am going to tell you, factors affecting ionization energy. Factors affecting ionization energy. First, two things you see, one is here, one case let us take this and another case let us take this one. First case. First factor is atomic size. Atomic size. If atomic size increases, then what is the effect on ionization energy? If atomic size increases, suppose for one atom atomic size is this, another atom atomic size is larger. Then when atomic size increases, the distance between nucleus and electron is increasing. This distance is more than this. Atomic size increases, distance between nucleus and electron is increased. Then the force of attraction exerted by the nucleus will decrease. By Coulomb's law, force of attraction, Z is the atomic number, E is the charge on electron, E is the charge on the particle divided by the distance, this radius r square. If this distance is increasing, then what will happen? Force of attraction will decrease. The energy required to overcome this force in comparison to this will be less if you are going to remove the electron. Thus, ionization energy decreases. In very short way, you can see, greater the atomic size, greater the atomic radius, lesser is the ionization energy. Second one, nuclear charge. Nuclear charge. Let us see this one. If nuclear charge is increasing, now you can also think, I have told you already, nuclear charge increases number of protons, positive charge. Then the force of attraction exerted on the electron by the nucleus will increase. And if you wish to remove the electron, then to overcome this stronger force, more amount of energy is needed. Thus, ionization energy is more. In very short form, you can say, greater the nuclear charge, larger, yeah, greater will be the ionization energy. More will be the ionization energy. More nuclear charge, more ionization energy. Now, next point, let us see. Like that, other factors are also there. Screening effect, penetration of subcells, stable electronic configuration, they also affect the ionization energy, but in detail you will study again in higher class. Now, or you can see my other study material, there I have given in detail. Next is variation of ionization energy in the periodic table. Variation of ionization energy in the periodic table. First point, ionization energy show periodic trend, all that elements. Ionization energy of all elements means ionization energy of elements in the periodic table. So periodic trend. In general, it decreases down the group and increases across the period from left to right. First, let us see one by one. Variation of ionization energy in a group. First group example I am telling first, group number 1. This is also called 1 or first A. Now, on the top, hydrogen is there, first element. I have told you 9 plus, its position is controversial. Then first point is variation of ionization energy in a group. In a group. Variation of ionization energy in a group. On moving down the group, ionization energy decreases. Reason: on moving down the group, ionization energy decreases. What is the reason? Because atomic size increases due to successive increase in the number of cell. If number of cell increases, atomic size increases. The distance between nucleus and the outermost electron will increase. The force of attraction exerted by the nucleus on the electron will decrease. Consequently, less amount of energy is required to overcome this attractive force. Thus, ionization energy decreases. Then on moving down the group, there is successive addition of cell. One cell is added on moving down, size is increasing. This is why there is regular change in the ionization energy. Here I am telling some examples. Lithium ionization energy is 520 kilojoule per mole. I am telling this in kilojoule per mole. Hydrogen is 1311 kilojoule per mole. Hydrogen in kilojoule per mole. 520 kilojoule per mole. and here 496 kilojoule per mole, 419 kilojoule per mole, 403 kilojoule per mole, 376 kilojoule per mole. See, on going down, hydrogen is exception. From lithium, you see, ionization energy is regularly decreasing because of increase in the atomic size. Reason, increase in the atomic size due to increase in the number of cell successively, one by one. Now, variation of ionization energy across a period from left to right: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Here is helium. In the first period only two elements are there, hydrogen and helium, that I am not writing. 2372 kilojoule per mole. Now see, on moving across a period, with the increase of atomic number, nuclear charge increases, ionization energy increases. Very short form, on moving across a period from left to right, ionization energy increases. Reason, this is the combined effect of some factors. Number one is nuclear charge increases with atomic number. Second one, number of cell will remain same. When you are moving from left to right across a period, number of cell remains same. Incoming electron enters the same cell. Like lithium, I have told you how many cells are there. 2 electrons in the first cell, 1 electron in the second cell. Beryllium, cell number will remain same. This is nucleus. In beryllium, there are 2 electrons, 1 more will be here. Like that, in boron, here will be 3 electrons. In carbon, 4 electrons. Nitrogen 5, oxygen 6, fluorine 7. But this number of cell will remain same. Then electron is coming in the same cell, does not screen the nucleus properly, and the result is nuclear pull on the outer electron increases, atomic size decreases. If atomic size decreases due to increase in the nuclear pull on the electron, then the result is what? More energy is required to overcome this attractive force for removing an electron from the atom. In very short form, on moving across a period, nuclear charge, or you can say effective nuclear charge, increases. Because number of cell remains same, and incoming electron goes into the same cell. So ionization energy is gradually increasing. Example, here see 520, its value is more, 899 kilojoule per mole, 801 kilojoule per mole, and here 1086 kilojoule per mole. Here now 1403 kilojoule per mole, approximate 1314 kilojoule per mole, 1681 kilojoule per mole, 2080 kilojoule per mole. You don't learn it. I am writing just so that it can fit in your mind. You can remember that, see how it is changing. But you have not learned this unnecessarily. You have to understand, see how it is changing. But somewhere there is exception. Beryllium greater than this, nitrogen greater than this. That in detail you will study in higher class, but something I will tell you in other class. Because of more stable electronic configuration of beryllium than this, it is having higher ionization energy than this. Oxygen electronic configuration and nitrogen, you see. Nitrogen electronic configuration is more stable than this. This is why it has higher ionization energy than oxygen. There are some exceptions. These you have to remember in case of period. Now today up to this only up to variation of properties in a period. Again next day next property, very interesting thing I will tell you, and also I will connect these things. I will tell you how are these useful in our daily life. Let me finish first these properties, then I will tell you. Thank you very much.